Hi everyone. This is part of my submission for the Machine Learning Foundations for Product Managers course. This is a final course project on the combined cycle power plant dataset. Uh, the combined cycle power plant uses a combination of gas turbines, steam engines, and heat recovery steam generators to generate power. The data set that we had a little over 9,500 observations of hourly average ambient environmental readings from sensors across four input features: ambient temperature, ambient pressure, relative humidity, and exhaust vacuum. Our objective was to predict the net hourly electrical energy output, which is a continuous numeric variable based on the hourly average ambient environmental readings from the sensors at the power plant. And given the fact that we need to make a prediction on a continuous numeric variable, I chose the linear regression modeling approach, and that is shown in the equation that's shown on the slide on the right side of target variable PE equals W0 plus W1 into AT, and so on. Um, Given that we needed to identify the most, like, the dominant input feature that correlates to the target variable, through AutoML, I found that the correlation rate for ambient temperature was the highest. But all four input features are required to be analyzed in order to get the most accurate predictions. And four different algorithmic versions were tested, and the two areas that across which the four versions were created were: one, slicing the data in a different way, which is the difference between version 1 and 2, and then 3 and 4. And looking at optimizing different parameters. So between version 1 and 2, optimizing root mean squared error, and on version 3 and 4, optimizing mean absolute error. The data was split, as shown on the slide, of 80% training, 10% validation, and 10% evaluation set. And through the analysis run by AutoML, you see that I chose root mean squared error as the selected output metric, because PE is a continuous numeric variable, so we would get the most accurate model looking at the lowest root mean squared error, which was in version 3. I eliminated or rejected version 4 because the root mean squared error was very high, as you see, of 8.772, compared to the others that were in the range of 3.2 to 3.13. And for the first three versions, I took one of the observations in the data set that you see grayed out at the bottom right side of the slide, of temperature 14.96, V of 41.76, and so on, to predict the target value. As you see, given how close the root mean squared error for the three versions is, the predicted target value was basically in the range of 0.000002. So all three versions pretty much operate at the same level of prediction interval of 95%. But given the lowest root mean squared of error of 3.131, I chose version 3 as the selected model. And on the next slide, it shows the generated version of the model in AutoML. So I want to share a screenshot from AutoML as well. And that's my submission for the course.